Yes, a 50-amp receptacle falls under the section described. The intent and use of the section is to provide requirements for temporary wiring and equipment used on construction sites. This includes the use of 6/4 cable to supply power to a ground box containing a panel board with individual branch circuits protected by ground fault circuit interrupters, or GFCIs. You are correct that when a circuit is ground fault circuit interrupter protected twice, it does not operate as intended. This is because the first ground fault circuit interrupter in the circuit will trip if it detects a ground fault, and this will prevent power from reaching the second ground fault circuit interrupter. A ground fault circuit interrupter is a safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing through a circuit and quickly interrupting the power if it detects a ground fault, which is an unintended path of electricity to ground. Ground fault circuit interrupters are commonly used in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and construction sites. There are several types of ground fault circuit interrupters, including receptacle type, circuit breaker type, and portable type. Receptacle type ground fault circuit interrupters are installed in place of standard electrical outlets and provide ground fault protection to anything plugged into them. Circuit breaker type ground fault circuit interrupters are installed in electrical panels and provide ground fault protection to entire circuits. Portable type ground fault circuit interrupters are designed to be easily moved and used in different locations. They typically plug into standard electrical outlets and provide ground fault protection to equipment connected to them. In the case of the 50-amp receptacle, it is not clear how it would be connected to the circuit. If it is connected directly to the panel board, then it would be protected by the ground fault circuit interrupter in the panel board and would not need to be ground fault circuit interrupter protected itself. However, if the receptacle is connected to a branch circuit that is protected by a ground fault circuit interrupter, then the receptacle would not need to be ground fault circuit interrupter protected itself. It is important to ensure that the circuit is properly wired and protected according to the requirements of the National Electrical Code, or NEC. The NEC provides detailed guidelines for the safe installation and operation of electrical systems. These guidelines cover a wide range of topics, including wiring methods, overcurrent protection, grounding, and ground fault protection. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. When dealing with electrical systems, always consult the latest edition of the NEC and follow all applicable requirements. Ground fault circuit interrupters are designed to protect people from dangerous electrical shocks. They work by constantly monitoring the current flowing in a circuit. If the ground fault circuit interrupter detects that current is leaking to ground, meaning it's flowing through an unintended path, it quickly trips the circuit, cutting off the power. This happens very fast, typically within milliseconds, to prevent a harmful shock. A common scenario where a ground fault can occur is when an appliance has damaged insulation and a person touches the exposed metal part. If the appliance isn't properly grounded, the electricity will flow through the person's body to ground, causing a shock. A ground fault circuit interrupter would detect this leakage of current and immediately shut off the power. The NEC mandates the use of ground fault circuit interrupters in locations where there's a higher risk of electric shock, such as bathrooms, kitchens, outdoors, and on construction sites. These are areas where water is often present, which can increase the risk of electric shock. On construction sites, temporary wiring is often used, and ground fault circuit interrupters are crucial for protecting workers from hazards associated with temporary power setups. When installing a ground fault circuit interrupter, it's essential to follow the manufacturer's instructions carefully. Ground fault circuit interrupters have a test button that should be pressed monthly to ensure the device is functioning correctly. If the ground fault circuit interrupter doesn't trip when a test button is pressed, it needs to be replaced. Ground fault circuit interrupters also have a reset button. If the ground fault circuit interrupter trips, you need to identify and correct the cause of the ground fault before resetting it. Repeated tripping of a ground fault circuit interrupter indicates a persistent problem that needs to be investigated by a qualified electrician. It is important to understand that a ground fault circuit interrupter is not a substitute for proper grounding. Grounding provides a safe path for fault current to flow back to the source, which helps to prevent electrical shock and equipment damage. Ground fault circuit interrupters and grounding work together to provide comprehensive electrical safety. Furthermore, it's important to distinguish a ground fault circuit interrupter from a standard circuit breaker. A circuit breaker protects against overloads and short circuits by tripping when the current exceeds a safe level. A ground fault circuit interrupter, on the other hand, protects against ground faults by tripping when it detects current leakage to ground. While some circuit breakers also have ground fault protection built in, a standard circuit breaker will not protect against ground faults. Temporary wiring on construction sites often involves the use of flexible cords and cables, such as the 6/4 SO cable mentioned earlier. These cords and cables must be approved for the intended use and must be properly supported and protected from damage. The NEC specifies the types of cords and cables that are permitted for temporary wiring and provides guidelines for their installation. It is also important to ensure that all electrical equipment used on construction sites is properly grounded. This includes tools, appliances, and extension cords. Grounding helps to prevent electrical shock and equipment damage by providing a safe path for fault current to flow back to the source. Regular inspections of temporary wiring and electrical equipment should be conducted to identify and correct any potential hazards. This includes checking for damaged cords, loose connections, and improper grounding. Any damaged or defective equipment should be removed from service immediately. When using ground fault circuit interrupters on construction sites, it's important to ensure that they are properly installed and maintained. Ground fault circuit interrupters should be tested regularly to verify that they are functioning correctly. If a ground fault circuit interrupter trips frequently, it may indicate a problem with the wiring or equipment connected to it. This problem should be investigated and corrected by a qualified electrician. It is also important to educate workers on construction sites about the hazards of electricity and the proper use of ground fault circuit interrupters. Workers should be trained to recognize potential electrical hazards and to take appropriate precautions to prevent electrical shock. In the specific case of a 50-amp receptacle on a construction site, it's crucial to consider the load it will be serving. A 50-amp receptacle is typically used for high-demand equipment, such as welding machines or large power tools. The circuit supplying the receptacle must be properly sized to handle the load, and the receptacle itself must be rated for 50 amps. If the receptacle is being used to supply power to a panel board with individual branch circuits, the panel board must also be properly sized and rated for the load. The branch circuits must be protected by overcurrent devices, such as circuit breakers or fuses, and ground fault circuit interrupters must be provided where required by the NEC. The use of 6/4 SO cable to supply power to the ground box is a common practice on construction sites. SO cable is a type of flexible cord that is approved for use in temporary wiring applications. The 6/4 designation indicates that the cable contains 6 conductors, 4 of which are current-carrying conductors and 2 of which are grounding conductors. When connecting the 6/4 SO cable to the panel board, it's important to ensure that all connections are made properly and that all conductors are properly terminated. Loose connections can cause overheating and arcing, which can lead to electrical fires. It's also important to protect the cable from physical damage. The cable should be supported properly and should not be run across walkways or in areas where it could be damaged by equipment. Finally, it's essential to remember that electrical work can be dangerous. Only qualified electricians should perform electrical work on construction sites. Unqualified individuals should never attempt to install or repair electrical equipment. If you are not a qualified electrician, you should always consult with a qualified electrician before working with electricity. The National Electrical Code, or NEC, is the standard for safe electrical installations. The NEC is updated every 3 years, and it contains detailed requirements for wiring methods, overcurrent protection, grounding, and ground fault protection. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements when performing electrical work. It is crucial to have a thorough understanding of electrical principles and safety practices. Electrical systems can be complex, and it's essential to have a solid foundation in electrical theory to be able to safely install and maintain them. This includes understanding concepts such as voltage, current, resistance, and power. It also includes understanding the different types of electrical circuits, such as series circuits, parallel circuits, and combination circuits. Additionally, it is important to be familiar with electrical safety practices, such as lockout-tagout procedures and the proper use of personal protective equipment. When working with electricity, always take precautions to protect yourself from electrical shock. This includes wearing appropriate personal protective equipment, such as rubber gloves and safety glasses. It also includes using insulated tools and avoiding contact with energized parts. Always de-energize circuits before working on them, and verify that the circuit is de-energized before touching any wires or components. If you are not sure how to de-energize a circuit, consult with a qualified electrician. In summary, a 50 amp receptacle on a construction site falls under the temporary wiring requirements of the NEC. It is important to ensure that the receptacle is properly wired and protected, and that ground fault circuit interrupters are provided where required. The electrical work can be dangerous, so it is important to take precautions to protect yourself from electrical shock. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. The proper installation and maintenance of electrical systems are essential for ensuring the safety of workers and the public. By following the requirements of the NEC and adhering to safe electrical practices, you can help to prevent electrical accidents and injuries.